How rude. I got cut off. But that's okay. I'm almost finished. But we left off talking about coronal mass ejections. And remember, that's sort of like, not to be too crude, but that's sort of like projectile vomiting, if you will. That's a tremendous amount of massive eruption of solar activity. And that's mostly going to be charged particles and some light, some EM radiation. So the Van Allen belts really do a great job protecting us. And if you remember, the Van Allen belts are there because of the Earth's liquid outer core, which spins rapidly and creates that magnetic field around the Earth. Whenever you have a moving electrical field, you're going to have a magnetic field accompanying it. Solar flares are mostly light or radiation, and they are quick bursts of energy from the sun. Quite a bit different actually from a CME. Remember, I said earlier, sunspots can signal solar activity that's coming along. So a coronal mass ejection, basically we sometimes refer to those as solar wind particles. And they have mass. They're ionized particles. They're charged particles, mostly ions with the electrons stripped away because of the sun's intense temperature and pressure. A CME is mostly plasma, mostly violent release of particles. And as I said before, it's sort of like a massive eruption. Think of it as a gigantic, if you will, um, just almost a projectile of particles out. Coronal mass ejections can take 3 to 4 days to reach the Earth, and that varies, but they actually move extremely fast. Now, they don't move as fast as light because they're not light. In most cases, they're charged particles, but they consist of protons and electrons, which is plasma. Protons have had their electrons stripped away, so they're just charged ions, and these electrons are moving in a soup of mixture known as plasma. And as I said, there's certainly going to be some light involved with CMEs as well, some X rays, some gamma rays as well. Now, to study the sun and figure out in what ways we can kind of know what it's doing and know what it's up to, there are several different satellites that have been deployed over the years. And one of them is known as SOHO. And SOHO is the Solar and Heliospheric Observatory. It orbits around the sun, it's in step with the Earth, and it faces the sun constantly, making sure it's keeping track of what the sun is doing. And you can go online and take a look at the sun in real time and see how many sunspots there are. I did that this morning, and there's just a very couple small sunspots. But remember, we're at the solar activity minimum right now. One of the strangest, weirdest mysteries of the sun is the following. At the surface, where you would expect temperatures to be brutally hot, and they are, but as you go away from the surface, you get up to the outer corona, the outer layer of the sun's atmosphere. And as it turns out, the corona's temperatures are hotter than the surface of the sun. Now, if you were out at a campfire and you were sitting right by the campfire, and it was a night, and it was a cool, chilly night, and you walked away from the campfire, and it got hotter and hotter and hotter the farther away from the fire you went, well, that would be weird. That would be a mystery. And that's what's going on in the sun. As you leave the surface and move up into the corona, the upper atmosphere of the sun, it gets hotter. The temperatures increase, and nobody knows why. And so they sent something called the Parker Solar Probe. It's been observing the corona and trying to figure out this mystery. And at its closest approach, it's 3.8 million miles from the sun. And astronomers like to say the Parker Solar Probe actually touched the sun. Well, not really, but that's awful close. Keep in mind, from the Earth, the sun is 93 million miles away. So the Parker Space Probe got up to 3.8 million miles from the sun. Luckily, it has a tremendously efficient carbon heat shield that protects all of the instrumentation behind it. And it always faces the sun, and it regulates itself, and it can turn if it finds its angle getting off, it'll actually turn and continually face the sun so the sun's energy is always hitting